So we do have our rule, our chain rule. And remember, it's one of the most practical, it's one of the most useful, but it's also one of the trickiest to really get to master. And it's not alone. If you look at the chain rule, it's not alone in that it's an additional step that needs to be taken, because you're taking derivatives using the old rules. You're taking f prime keeping g, g prime. So you're taking derivatives with the power rule, the quotient rule, the product rule, with trig rules. You're taking derivatives with those rules, but you have this additional u prime, you have this additional g prime, you have this additional du dx based on what you've been given. There is the box notation. It's not my favorite. We were able to on Friday. Yeah. On Friday, we did this crazy one, because it wasn't just an f and g, it was an f of g of h. Or you can think of it was an f of u of v, technically. If you want to think of it that way. And it was pretty intense. That's not how hard they all are, I promise. I just decided on Friday, with a little bit of time that we had left, that I would go ahead and show you a very involved one to see if that would help you with the idea. First of all, let's just recap real fast. Why did I move the fourth power to the outside? Yeah, I need to rewrite it, because what's technically going on is this is tangent x cubed times tangent x cubed times tangent x cubed times tangent x cubed, right? So I need to write this entire tangent of x cubed to the fourth power so that my brain realizes, remember the Matryoshka dolls? Who is the outer function? Who is the big operation going on? The outer shell in some senses. And so to the fourth power was our f. To the fourth power was our outer. And our inner, if we peel off the fourth degree, if we peel off f, now who's outside? Tangent. Good. So f was to the fourth power. Tangent was g. So then what does that make x cubed since it's not x alone? H. Yeah. H. And so h is in terms of x. That's where our x is. It's x cubed. So as you guys noticed, we did do the u notation. First of all, we said f is u to the fourth. Why did I say that u is tangent of v? Because there's another inside. Good. So u is an inside, right? U is an inside, but v is another inside, because I did have the tangent inside the fourth, but I also had the x cubed inside the tangent. Good. So x cubed is inside our tangent. So then we had to go ahead and take f prime of u, derivative of the f, which was 4u cubed, then u prime, which is secant squared of v, and then v prime, which was 3x squared. And as soon as you get to the expression in terms of x, you can say it's done, because the next step would have been x is equal to x, and the derivative of x is just 1. So we don't need to go any further since we've gotten to our x here. And then we just simplified by, I think, rearranging. We had to take our u, we had to plug that in. We had to take our v, plug it in everywhere there was a v. Oh, let me scroll down a little bit. And a couple of you, I think, got a little confused on Friday about where the 12x squared came from. But the 12x squared, remember, secant squared is of v, not of this guy. This guy can be rearranged. He can go before or before. Secant squared, once again, is of the x cubed. He's not of this guy. This guy can be rearranged to the front. So I just brought him to the front, multiplied. These ones are kind of stuck. We could make secant squared 1 plus tangent squared, but that just doesn't sound fun right now. For this one, once again, the outer was to the fourth, but this is function notation, composition notation, so we say x to the fourth. The tangent of x, and then x cubed is our final inner. And then we had to do our formula of, take the derivative of the outside, keep the whole inside the same, both of them. Then we peel off the f. Now it's g prime's turn, keep his inside. Then it's h prime's turn to be derived. And then x prime would just be 1. That's why we stop. So we took the derivative of this guy, bring down the 4, make it a 3, but who went inside? G of h. That stayed the same. Then times g prime, derivative tangent with secant squared, keep the inside, then times h prime. Rearrange. And this one, in words, it's easiest to go back up to see the function. In words, yeah, blot, right? Some of you like that on Friday. Blot. It's blot to the fourth. So block to the fourth, bring down the 4, make it a 3. Derivative of the outside. 4 block cubed, so 4 block cubed, times, then peel off that one. Now it's tangent's turn. Derivative of tangent of block, secant square block, and then peel off tangent. Whose derivative is it? Is it times 1? Yeah. Derivative of x cubed, which is 3x squared. Rearrange it, you got it. So, you guys have to think of this idea of outers and inners. You don't have to necessarily have mastered the f of g or the f of u or the dy dx notation or even the words. You just have to figure out which way works for you. And let's see, I'm trying to give a good illustration. I mean, if I was doing like a life talk kind of thing, I talk about how when we come to God with our desires or our requests, we have to come with open hands, not like clenched hands, saying this is what I want and this is all that I want. Like you have to come with open hands, being like, okay, this is what I want, but I know that your plan is best. Kind of same thing here. I want you guys to choose a rule where you're like, okay, I think this is the one I like, but don't totally ignore the other variations because sometimes one form might be easier than others. So don't just say, I like the words because it's short. Yeah, but if you don't have a mastery of it, you don't follow the proper steps, sometimes the words will read you wrong. Same as with some of the other ones. Okay, let's just go to some easier ones just for a second. These were some of the examples from the beginning of notes. We talked about outsides and insides. Talked about F's and G's, F's and U's. So these are easier examples, not near as bad as that tangent to the fourth. Okay? And you guys already identified in your notes, if you want to look, I think it was the first page of notes. Was it the first page of this section? Where we had these examples. And what do you think of it with F's and G's or with F's and U's? I'm not going to do words initially right now just because I don't think we have enough mastery of it. But who was, for this one, who was, let's do this one with F and G notation. Who was the F of this one? Sine of X. And who is the G of this one? 6x. So then how does my chain rule work if I need to find the derivative? F prime of g of x times g prime of x. And if it helps, you could technically find these pieces off to the side, outside of the rule, and then plug in. Who is f prime? Cosine, right? Who's g prime? What's the derivative of 6x, guys? Good. So then, using this formula, using the chain rule, we would say derivative of f is cosine of who? Yeah, we'll get there. I just right now plugged in g of x, that's technically a good rule. Take f prime cosine of and put in g. And then g prime of 6 is 6. Sorry, g prime of x, I said 6 in that. G prime of x is 6. So then we can say 6 cosine of 6x. Now, can you guys see how the words would work on this one?
Sine of block.
Yeah. What's the derivative of sine of block?
Cosine of block.
Cosine block, which is cosine 6x. And then, what do I still need to remember? Derivative of?
So 6x,
So 6. So if you think of it, derivative of the outside, keeping the inside the same. Derivative of sine is cosine. Keep the inside the same of 6x. Cosine of 6x is this one right here. Times derivative of the inside would be 6. Or as I was saying on Friday, u prime. Remember that one? U prime. We need that at the end, so we needed the times 6. For this one, let me use u notation, but let me go ahead and make a little bit of space. I can do an entire page. I think you guys can still see it, right? Closing out a little bit. Okay, let's use u notation on this one. Who's the u? Yeah, we do have f of u is equal to square root of x. And who's our u? Good. So we think of f prime of u, sorry, not square root of x. Yeah. We only need the x's up here in this notation. This one we get to use u's. Could we rewrite that just to make it easier for our purposes? We could make it instead of square root of u to the positive 1/2 power, because it's not in the denominator, so u to the 1/2. So So f prime of u would be 1/2 u to the negative 1/2. U prime would be 2x. Sorry, that u prime looks pretty atrocious. U prime looks pretty atrocious. So then, chain rule would say, how to take the derivative of f of u? Good. F prime of u times u prime. F prime of u times u prime. So you bring down the 1/2. Take the u, who is x squared plus 1, the negative 1/2, times 2x. Pause. Does that make sense? F prime of u times u prime. And for those of you guys that you need to see the formula. Since I have an f of u. No f of u of v, just one outside, one inside, that's it. Oh, I did not put the prime, I'm sorry. That's a struggle. F prime of u times u prime. So we have 1/2. I plugged in the u, because we want to get it all back to terms of x, to the negative 1/2. Now, guys, we know to make it match, or maybe we don't, but to make it match, should I simplify?
Yeah, probably you can simplify.
Yeah, what can I do with the 1/2 and the 2?
Well, those cancel, and then so it's just x over square root of x plus 1.
Good. That would be a good make it match. Now remember in pre-cal you'd be like, oh, we have to get rid of the square root, but remember in calculus. Ain't nobody got time for that, right? Ain't nobody got time for that. Because the multiple choice answers, most of them won't rationalize either, so it's a good thing for us to stop.
On the AP test.
Okay, so what was easier about both of these than that crazy, I'm going to come back to this page, than that crazy tangent to the fourth one? What was easier on this page?
There wasn't no AP.
Yeah, did you see it? There was just one outer, one inner, that's it. But were the rules any different technically about the process? No. Come back to the, come back. I'm sorry. Derivative of the outside, keep the inside the same, times derivative of the inside. Think of our Matryoshka dolls. If you're taking the derivative of this guy, you're taking his prime, but you're not changing his insides. You haven't gotten to them yet. You have to take his prime, keeping everybody the same. What's an example of that? Right here. Take the derivative of sine, make it cosine, but it's cosine of 6x. You got to keep his inside in there when you take the derivative. Take the derivative of the outside, keep the inside the same. Then go ahead and peel that off. Ignore the cosine. Look at 6x. Take his derivative now with multiplication times 6. Down here, same thing. What you see right now is a square root or a 1/2 power. Take the derivative of the outside, but you got to keep the inside the same. Bring down the 1/2. Make it negative 1/2, but you got to keep the inside still in there. Then peel off the square root, peel off the 1/2, and now say times, okay, now it's u's turn. Now it's his turn. Times u prime, and then go ahead and simplify. Does that kind of make sense, guys? So same thing with the tangent to the fourth. The first thing we did was deal with block to the fourth. Bring down the 4, make it a 3, but we left all the inside there. Then peel off the fourth, and then it was time for tangent. Derivative of tangent secant squared. Keep his inside, it's still in there. Then finally you get to the x cubed and you get the 3x squared. So let's go ahead and see how, these aren't going to be forever cards, because the rules are already forever cards. But let's see how with some basic examples, maybe you don't have to write all the f and the g and the f of u and u. Maybe you can do them a little bit quicker, thinking of just the words and the idea of chain rule. So yes, it's a rule. Yes, we're writing it down, but no, we're not really making it a forever card. It's more of an understanding of, hey, if I just have something nasty squared, or to any power, to the 10th, I can think, because of chain rule, to take derivative of u to the n. Just make it n times u to the n minus 1 times u prime. Right? And that's using the rule. That's using chain rule, just saying like, hey, all right. Maybe it's not always as hard as having to write f of x and g of x. Or f of u, and then writing the rule and plugging into the rule. Maybe we can get just a natural understanding of chain rule and be able to go a little bit faster. If I were you guys, I would skip like 2 lines in between the examples. I'm just trying to give you plenty of time to get down this so that we can work together on solving. Sam ended up coming up to times you prime. Think of it this way. Doesn't really work with the Matryoshka dolls. And this example always gets super awkward, so I'll try not to get too in depth. I used to talk about, and it's actually why there's a bunny on the, every time you do this, a bunny dies. I'll show you for those of you guys that, can you see it?
Yeah.
It's behind the smartboard, right? Okay. Every time you do this, a bunny dies.
Yeah.
Why?
Because you could multiply by.
There's something within something.
No U prime. It's not just cosine of 6x. It's cosine of 6x times
6.
Yeah. This is what was missing. So the final answer should be 6 cosine of 6x. The reason it was called the bunny rule is because before I figured out the Matryoshka thing, I think that was a random thing I figured out last year. Maybe it was 2 years ago. Thinking about peeling off layers. Before, I just was like, oh, hey, times U prime, multiplication. Like, bunnies multiply. That was the end. So then it was like, oh, hey, it's pretty much like as soon as the bunny comes out, like it just matures really fast and it's able to multiply. That's why you guys know nothing about bunnies. Like Fibonacci sequence came from bunnies because they would like multiply, 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 multiply. Like bunny farmers know they multiply, multiply, multiply. Anyway, they just mature super fast, and so their ability to reproduce, it comes really quickly after birth. Like not the day after, but. So then it was like bunnies multiplying. So then I tried to have this old like the mama bunny and the baby bunny, and you have to like take the derivative of the mama, but the baby's still inside. And when the baby comes out, pretty soon it'll have a baby. Anyway, yeah, it was just weird. But anyway, why did I say all of that? Multiply.
Multiply by U prime.
Multiply. Somebody asked, wait, what do you do to U prime? You multiply. Always, always. Hopefully that gives you a non-disturbing mental reminder of multiplication. It's going to be the bunny rule. Don't kill bunnies. Oh, bunnies multiply times U prime. Hey, you're welcome. Okay, so coming back. Okay. Matryoshkas are better.
Don't ruin your grandmother's Matryoshka set.
Oh my god. Anyway, coming back. How do we take the derivative of this guy? Who's U?
Tangent x plus 1.
Okay, so maybe instead of the whole f of u thing, and maybe we can just think of u. So u is tangent x plus 1.
That's what it is.
Who's u prime?
X squared.
Ah, do you see why we need to memorize those forever cards? Because they'll go way, well, they'll just go way faster if you have them really well memorized, right? Secant squared, oh, I have not updated those forever cards online. We even talked about them Friday. Okay, plus 0. Goal today.
Coffee or day for I think Thursday.
I know, right? Struggle. No. I need you guys to memorize ASAP, like today. Derivative is tangent and secant squared. So what do? This is u squared. How would you get the derivative of u squared? This whole thing is u squared. It's 2u times u prime. Right?
That makes so much more sense.
Yeah, doesn't that help? Like, as long as we get the idea of chain rule, maybe we can make some of these easier one outer, one inner ones faster. Just think of whatever's the blob, think of it as u. So it's u squared. Oh, it's 2u. Oh, that's right. U prime. Just don't forget your u prime. So if you forget your u prime, the poor little bunnies that should be multiplying are dying. Okay, so, you're welcome. Why did I say skip 2 lines? Because the secant squared probably needs to come in front since he just has an x. Now, kiddos, here's a struggle, and I've actually seen it messing people up on a test question. I don't remember exactly when that test question comes, whether it's this test or a future one. Question. Who is tangent of in this problem?
Yeah.
Well, that's what I'm saying now. If there are no parentheses written, who is tangent of?
Just the x.
Is it x plus 1, or is it just x? If there's no parentheses.
It's just x.
Yeah. But a lot of people would think it should be the x plus 1 to get really, really confused. If there are no parentheses, it's hard. If there are no parentheses, tangent is of x alone. It's tan x plus 1. Tan x.
Don't you have to draw parentheses around tangent?
In order to have it x plus 1, you would need the parentheses, but they're
No.
there's
They're like on the outside. Yeah,
Like parentheses 10x plus 1 parentheses.
Oh, I just didn't even do that. Yeah, sorry. I was too focused on this part. But tan x plus 1. Does that make sense? No parentheses. Then it's just tangent of x. I'm just preparing you for a future test problem someday. Number 2. Who's my u? Who's my u? Ah, 4x. Okay, so wait, pause. I'm not saying anything. You guys find the derivative. Go.
Oh, I did in my head.
You already saw it. Good. Wait. U to the 10th, right? You already got it?
Yes.
So u to the 10th, what's the derivative of u to the 10th? 10 u, careful, to that. Don't forget that part. It's good if you bring down the 10, but don't forget to make it the 9th. Sometimes you get so focused on having the u, you forget the other power. So 10 u to the 9th times 0. You guys simplify? Yeah. Because you can rearrange multiplication. This to the 9th can come out here, 4x can come in there, it's really just 40x, right? Now, can I bring that in, yes or no?
No.
Not unless you want to raise him to the 9th power first, and then bring in 40x. Otherwise, he is not allowed to enter it.
Pascal's
It's not binomial theorem.
Pascal's
Pascal's! 1, 1, 2, 1, 1, 3, 2, 1, 1.
It's somewhere in this room.
Okay. Does that make sense? Does this page make sense?
Yeah.
Okay, so what happens if we go to trig? Can we shorten?
Oh, it gets ugly.
Does it?
Well, yeah.
Can we shorten what to do when we have a trig of u? Yes. Once again, this is not a forever card. I just need you to know the basic rules from forever. 13,
Yes.
I think.
That's true.
And then just realize if it's a trig of a u, now if it's a trig of a u of a v, if it's an f of a g of an h, we have some trouble. But otherwise, if it's trig of just a u, we just do the rule. Hey, this is a good review of the rules. And multiply bunnies u prime. I'm showing you an example in number 3 down below. Which is why we want the tangent of 5x to be able to go quickly. Because a chain rule could be inside a product rule. A chain rule could be inside a quotient. It could be just one step to a whole process. And it is rough unless we can simplify with u notation things like tangent of 5x and just make it tangent of u. Go and just get this guy here. There's some of you that don't feel super solid on product rule yet, or trig rules. As you write the rules, I'm just kind of rewriting this guy to see if it would help you in solving. Not with f's and g's, not even with f of u's notation. And ironically, we kind of practiced this last year. The idea of a u, when we had something gross like a quadratic with trig inside, and some of you just were like cosine squared x plus 2 cosine x plus 1, like how do I, there's a cosine. So I was like, no, don't worry. Make u the cosine, ignore the cosine for a little while, and come back to it. I was kind of introducing this notation to you. Not derivatives. Not slopes of tangent lines, but just the fact that we can use a u to make things simple. Now, Charlotte said just a second ago, wait, don't we need to use the multiplication, the product rule? What do you guys think? Do we need it?
Yes.
We have a first and we have a second. Does that make sense? We have a box, we have a triangle. Find the derivative. If that notation helps, we have to use the product rule because we do have a product. So, you guys caught up? Is it okay if I go? We have a first times a second. We have the u's identified. What is the product rule? Second?
First.
Okay, so pause. Second would be tangent, right? D first, what's the derivative of x squared?
First is 2.
Plus first, D second,
Which is, what is that? That's
secant,
squared x u.
secant squared u times u prime. Wait, pause. Do you see what I'm doing? Instead of looking at the tangent of 5x, I'm thinking about it as tangent of u. And look up here, tangent of u can just be the rule, secant squared of u. But what do you need because it's chain rule? U prime. Right? So I have second d first plus first d second. His derivative is secant squared of u times u prime. Now what do I have to do to finish the problem? Who's u? Me?
Plug in the u and u prime.
So this one's going to be, I move the 2x in front because usually we want the trig to be last. But plug in 5x for u. This one will be x squared times secant squared of 5x times 5. Pause once again. You guys don't see parentheses on your trig right now, right? So who is tangent naturally of? 5x. Who's secant squared naturally of? 5x. So what can I do with this 5? The u prime? Good. So I can say 2x tangent of 5x plus 5x squared secant squared of 5x. You guys realize if the parentheses aren't there, the trig is just of what immediately follows. Not the 5, but the 5 times x. So if you need the parentheses, you can put them in, but realize they don't have to be there. Is that okay? So far we've talked about what if you have u to the n times u to the n minus 1 times u prime. What happens if we have sine of u taking the derivative? Cosine of u times u prime. What happens if we have cosine of u? Negative sine of u times u prime. Derivative tangent of u, secant squared of u times u prime. Derivative cosecant of u, negative cosecant u, cotangent u, keeping the u's, times u prime. Just one. Derivative secant of u, secant u, tangent u times u prime. And last but not least, derivative cotangent of u, negative cosecant squared of u times u prime. Exactly. Right? Chain rule. Don't forget to multiply. So, you guys gonna help me out? What number example are we on? I have no idea. 3? 4? But we've done other ones before that. This is 4 and 5, I think. Does that make you know the numbers
It's a
red?
plus sign.
Okay.
Alright.
Plus, okay, that makes sense.
That does make it easier.
I don't want to start a new page in those.
However, don't get tricked by the trig notation. Can we rewrite this to help us just a little bit first?
I'll get to the 4th, yeah.
You bring the 4 outside.
Yeah, we could rewrite this. Oh, sorry, we're not taking the derivative yet, we're just rewriting. What should you do every time you see trig to a power?
And move the power out.
Wait, then you don't need to say sign.
Question, do you need to think chain rule, yes or no?
Yeah.
Who is u?
Sign
Sign
x.
Sin x. Who's u prime?
Cosine x.
So couldn't I even rewrite this one more time? If you need to rewrite it, if you're still trying to learn it, isn't it just 5u to the 4th? Does that make sense? Okay. So now let's take a derivative. What's the derivative of 4x? What's the derivative of 5u to the 4th?
Yeah.
U Q times
U prime.
no high places today. Thank you.
Like a song.
Ask Maggie. She like all the forever cards 1 through 5. She made a song for everyone.
Oh
So
my
she said,
gosh.
Huh?
Is that what she's singing?
Yeah, that's what she was trying to sing on Friday. She hadn't sung it since the quiz, so she didn't remember all of it, but she recorded it so that she could remember it. 20. U is U prime is cosine. Oh dear. Now pause. Can you also think the words? Flop to the fourth. Bring down the 4, derivative of the outside. Bring down the 4, make it a 3, right? Bring down the 4, that's 20, make it a 3. Keep the sign, times derivative of the inside cosine. You can use the words too. Guys, this is pretty good. Not too shabby. I guess we could pull out a 4, but whatever. I feel like you guys could factor out a 4 if you needed to for an answer. But I'm going to put this back into notation. So where's the Q need to go?
After the sign before the
Yeah. There you go. Don't get tricked by the trig notation. I need. I promise it'll help. I need you to rewrite anytime you see a power in a trig. Okay? Alright. You guys, ready, set? I'm not giving you any help. Go. You can work in your groups if you want.
Oh boy.
You got it.
So ugly. Honestly, it's so ugly. I don't think I can simplify it more. Did I do this wrong?
You lost your X. That's why you're confused. It's next to the one. It's tangent of who? Like that would be. Does that make sense? Yeah. Oh, because the those of you that got it, check with your group, make sure they're on board.
Yeah, that's right.
Hold on, who's outside, who's inside?
Yeah, that's right. Just plug
Needs to
into
be
your
the
what's
It'd be square root of X, right? Then use your 1/2 power to help you for you. Does that make sense? Yeah. Outside, inside, use the inside. You guys all got it?
Okay, so what's your U?
I mean, I have this. This is right here. But when I make that, then
Yeah.
all over.
So then, what's U prime?
Is that at the top?
Well, then we can either roll
Move the 1 because you can do X to the 1/2, so move the 1/2 power in front. So you have 1/2 times, what's 1/2 minus square root?
But I just moved it. To
That's after.
oh wait, 2?
Yeah.
Oh yeah, 1.
If you simplify that, that's 1 over 2 square root of X.
Square root.
I think that would be nice. So then,
You guys have a second. Why don't you look on up and see if you agree?
secant square.
It was tangent of, even though there wasn't parentheses, tangent of u. U needed to be square root of x. Rewriting it as x to the 1/2 makes it easier to take the derivative. Derivative of tangent of u is secant squared of u times u prime. Now pause. What could be an easy mistake that like a pre-cal kid's like, oh, you should have simplified. What would they do if they came in? And cross those off. The question, isn't square root of x inside secant? Can I go crossing him off with anybody?
Do it.
No,
Do
he's
it.
trapped!
Do it.
In a good way, I think. I don't know. Kiddos, look up here at the board. Ready?
Yeah.
We didn't work today so much on speed. We worked on accuracy, whether you would be able to correctly apply the rule. You need to finish this homework tonight and come tomorrow with questions. The test is coming. Sound good? All right, get out of here. Thanks for the extra 30 seconds. Sorry, guys. Happy Monday.
See you, Miss Dave.
See you guys.
Oh, my gov book I left in
Have a
my
good day,
locker.
everybody.
Aw.
You forgot what?
My gov book in my locker.
Ah.